This naturalrefrigerants.com article is being read by an automated voice. Greener Reefer Transition Alliance introduces simulator showing emissions and cost savings from switching to natural refrigerants by Michael Gary, published April 8, 2026. The Greener Reefer Transition Alliance, a collaborative industry initiative led by the GIZ, German Society for International Cooperation, has introduced an emissions and cost simulator that compares refrigerants used in maritime containers, reefers, across real-world trade routes. The free online reefers emissions and cost savings simulator allows users to input variables including route, key cargo, carbon pricing, and refrigerant and fuel costs. It enables shippers, logistic operators, and policymakers to quantify the benefits of natural refrigerants, propane and CO2, in reefers compared to synthetics, including R134A, R1234YF, R404A, R513A, and R452A. Natural refrigerants can turn decarbonization into a strong business case, said Gordon Wilmsmeyer, director of Hapag-Lloyd Center for Shipping and Global Logistics, CSGL, at Kuna Logistics University, KLU. R290 in particular achieves CO2 reductions at a strongly negative abatement cost, indicating both environmental and economic benefits. The simulation tool was developed in collaboration with CSGL at KLU, with support from the International Climate Initiative and the German Federal Ministry of the Environment, Nature Conservation, Nuclear Safety, and Consumer Protection. Wilmsmeyer showcased the simulator in an Alliance webinar. The details: the user selects the vessel, IMO number, product, container size, cargo load, route, and market prices. The simulator accounts for the product's storage requirements, the route's ambient temperature, the vessel's technical specifications, the refrigerant charge, and the leak rate. The simulator quantifies each refrigerant's environmental impact, including greenhouse gas emissions, direct and indirect, TFA, trifluoroacetic acid, emissions and carbon abatement, defined as the avoided cost per kilogram of CO2 TFA is an ultra-short-chain PFAS, per- and polyfluoroalkyl substance, often referred to as a forever chemical. The model translates technical performance into monetary values with a breakdown of total costs for each refrigerant. An example: Wilmsmeyer modeled shipping bananas from Guayaquil, Ecuador, to Hamburg, Germany, on board the vessel Polar Ecuador, IMO 9786774. He put in average parameters for intercontinental shipping. R290 and CO2 eliminate TFA and direct GHG emissions. For the simulation, propane offers the most cost-effective refrigerated reefer. Compared to R290, annual costs per container were roughly $50, 43 euros. Higher for CO2, $350, 300 euros. Higher for R134A and R1234YF, $450, 390 euros. For R513A, $1,000, 870 euros. For R404A and $1,200, 1,000 euros. For R452A. Making it possible to accelerate the transition to natural refrigerant maritime shipping, the GIZ is supporting R290 reefer development and CO2 reefer training. In collaboration with the GIZ, Thermo King, a brand of Train Technologies, will test a direct expansion R290 proof of concept reefer in June with a Costa Rican fruit producer. The GIZ's South Africa implementing partner, the National Ozone Unit of the Department of Forestry, Fisheries and the Environment, will conduct a 5-day CO2 reefer training course in Cape Town from April 20th to 24th. Quotable: current reefers use harmful synthetic refrigerants, thousands of times worse for the climate, with severe health risks from forever chemicals, Wilmsmeyer said. By starting the transition now, the entire fleet of reefers can be safe, PFAS-free, and climate-friendly by 2040.